Sorry about that. I just called him. He's doing it.
Yeah, it's on, Devika. Devika, it's on.
It's on?
Yeah.
Okay, great. Sorry about that, Ashwin.
No problem.
Over to you.
Okay. Yeah, thanks, Devika. And it's a real pleasure to be here. I'll start my talk. Okay, is my screen visible?
No, not yet.
Not yet. Yeah.
Yes.
Okay, so I'm going to be speaking about citizen science today, as you all know. I'll come back to the significance of this map later. So I'll start with what is citizen science? So I suppose our general understanding is that it's public participation in scientific research, not just professional scientists, but everybody in the public, any interested person contributing to science. But in more detail, it's the public involvement in the entire process of science, from getting ideas to asking questions, some of which you've gone through earlier in the course, designing methodologies, analyzing the data that comes out of it, and generating publishing knowledge. So the entire process. And this often involves collaboration with professional scientists in various capacities. So why is public participation important? It creates a global community who understand birds well, appreciate them, and cherish them, which leads to better knowledge generation and conservation of habitats. There are many questions that cannot be answered through more conventional science. I call it professional science here, people who are actually employed to do science versus the general public. And because scientists are so few, citizen science involving general participation can answer many questions that conventional science cannot. And we generally progress as a community with increasing scientific temperament. So citizen science in ornithology is very old in India. I'm going to focus on India alone. And one of the earliest citizen science initiatives to monitor birds in India was the Asian Waterbird Census. And this began in 1987. Since then, a number of online possibilities came up that allowed people to discuss about birds, to ask questions and learn from each other. And some of these platforms included India Nature Watch, which was largely a photo sharing platform, but also a place for people to learn from each other, learn from bird watching experiences. And Yahoo Groups, which was an excellent discussion forum. One of the earliest platforms where you could online platforms to document birds was Migrant Watch, which began in 2007 and went on till 2014. And it actually encouraged many bird watchers like me right then to actually do something more. And this is an opportunity that all of us, that I think many bird watchers were looking for, to have something more happen with their daily bird watching observations. So I would put records of species like rosy starling, gray wagtail. Whenever I saw it come down into India, these are migrants, and whenever it would leave. So this was followed by the advent of many online tools and platforms. There are thousands and thousands of birdwatchers in India, and these online tools and platforms allowed a simple way for people to actually collectively aggregate information and collectively contribute towards scientific initiatives. So there's the India Biodiversity Portal, eBird, iNaturalist, Biodiversity Atlas websites, and many others that have sprung up to be able to collect information for various taxa, not just birds. I've mentioned some that are somewhat specific to birds. And many other programs came up to monitor birds. There's a great backyard bird count that began in India in 2013, a common bird monitoring program, Pongal bird count, Bihu bird counts, Onam bird count. Many of these bird counts associated festivals that people were interested in coming together and counting birds for. The Salim Ali bird count, and many others. So all of this together led to a pretty rapid rise in public participation in bird monitoring and in citizen science. And I'll use eBird as an example to demonstrate the potential and scope of citizen science and where we are today as well. So coming back to this map that I showed in the beginning, this is a map of observations uploaded by birdwatchers to eBird since 2014. And what you see here is this map largely traces the boundaries of the country, which shows the spread of birdwatching and the spread of bird monitoring through eBird. There are over 25 million observations now, 1.5 million checklists, 25,000 observers, and all species that have been recorded in India are now on the platform, which is 1,350 species. Some of this growth can be seen in the growth in GBBC participation, which is the Great Backyard Bird Count, which I just went through. Now, just the number of checklists and person hours, total checklists, all of these metrics are growing really rapidly over the years, and you can see this constant growth, and it continues to grow. So what can we learn from citizen science initiatives? There is this large database that has built up. There are a number of people interested in participating in science, interested in doing more with this data that has been generated. What can we learn? We can learn about species distributions, where birds are in space. We can learn about seasonality and migration. When are they arriving when do they arrive in a place? When do they leave? Do these timings change? Or have they been changing over time? About the phenomenon of migration. There are systematic bird monitoring initiatives, unlike what I spoke about, which is unstructured bird monitoring, in that people can observe birds whenever they want, wherever they want, and there is no consistent protocol. Whereas bird atlases and other systematic efforts have consistent protocols, and there are learnings that can emerge from this. And then can learn about status and trends, and I'll explain how later. And this knowledge can come from both inbuilt tools in all of these platforms. Platforms like eBird or iNaturalist have inbuilt tools that help you explore birds. And there's a lot to learn from there. And that learning can lead to many questions that can then be asked and answered. Also by downloading data. Most of these platforms and all of these platforms have and should have data publicly downloadable. And any of you can download this data and answer any question that interests you. Of course, a question that's applicable, that can be answered with that data. So I'll start with some learnings that are possible from inbuilt tools on eBird. And again, I'm using eBird as an example here. So on the eBird website, on the eBird India website, there is, this is what you will see. And there is something called Explore. So you can explore, and when you click on Explore, this is the page you get. Click on bar charts. Select any region of interest. You can select states, you can select districts. So here I'm selecting Karnataka, which is where I'm based. Select that region and click continue. You'll be able to view bar charts for a range of species. It's an immediate way to understand seasonality. So for example, here, this is what I'm going to see. I can see that lesser whistling duck in Karnataka is not a migratory species. It's resident year-round. You see the bars, the width of the bars tells you how frequent it is during every week of every month of the year. Right? You see it's divided into 48 different sections. But a species like bar-headed goose appears to leave end of March back to its breeding grounds and arrives only in early November greatly. So the large period when it's not there. So it's migratory to the state of Karnataka. Similarly, you can see species like gargany, northern shoveler, ruddy shell duck, all of these are migrants to the state. So to understand more about when birds arrive, when they leave, I suggest you explore bar charts. You can also compare between years, I think, and this is extremely important in today's scenario of climate change. It's so many changes happening every year, El Nino events, etc. So it's important to see what is happening over multiple years. Are birds behaving differently during different years? So click on the line graphs icon near northern shoveler. I'm using northern shoveler as an example here. And then click on change date and select the last 5 years, 2018 to 22. So that's when you can look at, you can compare across multiple years. And this is important. This is also part of the assignment. So I suggest you go and explore this. And this is what you will get. You will see that there are differences every year. So for example, in 2019, the frequency is the proportion of checklists in which a species has been seen. And in eBird, bird watchers upload checklists, right, which are lists of birds. So the proportion of these lists in which that species, in this case northern shoveler, was present. So you see that in 2019, in January, northern shovelers were reported more frequently than in during other years or other times of that year. But here there's no clear pattern, right, between years. We can see that it's arriving and leaving, but but are there differences between years? Not very obvious. So such annual insights can help you develop questions about migration or climate or any environmental or habitat changes that might change how much birds are using that area or that state or district. In this case, there was no pattern, but I'd like you to look at other species to see whether you're finding other species with fluctuations between years. And there are a number of species, and I didn't show an example here. I'd like you to look at examples of find species that show annual fluctuations, right? What you can also do directly from a platform is to learn from images. And a platform like eBird, which hosts media and the Macaulay Library, has a vast repository of images to learn from. And as you can see, it's over 25 million images from the world. And I think over a million, much more than that from India. Don't remember the number, but a really large number of images to ask many questions about plumage, about changes in plumage over time, even about molt timings. You might have learned something about molt, about differences geographically in plumage, etc. There are many questions to ask. So what can we learn from the citizen science initiatives? I listed them down earlier, and I'm going to go through them one by one. So we'll start with distributions. So distributions is something that all of these platforms allow you to view directly on the site as well. But through a little bit of statistical modeling, you can get far more associations with where a species is likely to be present based on habitat and latitude and observations on these platforms. So this is from eBird. And a species like Blythe-street Wobbler, a tiny bird that migrates all the way from northern parts of Eurasia down to India, can see where they are there during the breeding season or where they breed, the areas that they pass through during, the dates are given April to May. So there's spring passage, but not autumn passage. Autumn passage, there wasn't enough data to estimate autumn passage here. And then you have where they spend the winter. So it appears the Indian subcontinent hosts the entire population of the species during winter. Another example, Indian blue robin, a species that breeds in mid to high elevations in the Himalayas, across the Himalayas, not just the Indian Himalayas. And it migrates through, it spends the winter in the Western Ghats in Sri Lanka largely, and it migrates through West Bengal, Bangladesh, and other parts of Northeast India on its way back to its breeding grounds. And again, you have the pre-breeding migratory season given here. So you can see there is a relationship with both topography and latitude about where they are there during different times of the year. So these outputs you can view directly on the eBird page in science products, and I suggest you view them, and all of you can use the data to generate such outputs. Something I'll get to later. You can discover new phenomena like with distributions when using photographs that have been uploaded. So, for example, Indian Paradise Flycatcher, there are two morphs. For males, there is a rufous morph and a white morph. And a number of birdwatchers have asked this question of where is there any geographical pattern, or is it age related? Do rufous morph birds always become white? Right. So that's a question that a number of us have had. So looking at data uploaded to eBird and photographs uploaded to eBird in particular, can see that this is the distribution of the species. So it breeds in some part of the Himalayas, but it's also present year round in many other parts of the country. And there are some places where it's only there during winter. But what we find from photos during the breeding season is that in Sri Lanka and South India, during the breeding season, it's almost only rufous morph birds. Whereas as you go northwards towards the Himalayas, this proportion changes largely to white. And in places like Sri Lanka, there are no photos of white morph birds during the breeding season at all. And a number of photos exist of rufous morph males breeding. So, which indicates that it's the age-related hypothesis here that all rufous morph birds become white is simply not correct. There is something more complex going on. That in South India, it's mostly rufous morph birds. In the north, it's mostly white morph birds. But what maintains these ratios that you see in other parts of the country? Do Himalayan birds also go through a rufous morph? It appears to be so. Are the same rufous morph birds becoming white, or are they? Is there any ratio maintained? Do some adults remain only rufous? Do some adults remain only white? So these are many questions that arise from this analysis. It's a fairly simple analysis from a data set that's available to all of us, but it raises some of these questions and gives answers. I suggest you look a little more at this graph and see what else you can interpret during other seasons. But what you can see in winter is that white morphs also come down south. So there's mixing during winter. You can also discover new species or new taxa using this. For example, black-breasted weaver. So black-breasted weaver is a species that is endemic to the Indian subcontinent. And it's present in northwestern India and North India, in the south, in the east, in various places. But this is an example of real citizen science, in that this entire study from the idea to the publication was conceptualized by birdwatchers in a WhatsApp group. So the idea came up there, where people discussed with each other saying that I've only seen black-breasted weaver with a black face, and some others said they'd never seen that, and where they were, black-breasted weavers in breeding season had white faces, which was really surprising to people who in another part of the country, who mostly watch birds in North India. People who watch birds in the south had never seen the image in the north, in the top right corner. So this led to some discussion and some questions asked, and then this group of birdwatchers got to the database and checked, is there any geographical difference? Is there something here? Are black-breasted weavers different in the south and east of India compared to the northwest of India? And it appears that that's indeed the case, that there's a clear divide in where black-breasted weavers are white-faced during the breeding season and where they're black-faced during the breeding season. And this now provides, again, an interesting question. Why are these so? Is there any geographical barrier that has caused this? The paper also suggests that there's been a recent influx into the south. Black-breasted weavers have moved into the south in recent times, and these are the white-faced ones. What was the historical biogeographic boundary? And are these new species at all? So, and this is something, these are questions for ornithologists, professional ornithologists perhaps, to take up now and answer. Migration, on to migration. And there's potential for incredible global perspectives. This is something that we don't have from many of the resources otherwise. we don't get to see migration in action, although there's some phenomenal work being done by ornithologists using satellite tracking, using tags, using flags and rings. But this gives a larger perspective. So how can you do this? How can you plot migration on a map? Download data for any species, eBird data, generate snapshot bird distributions at regular intervals throughout the year, right? In January, in February, in March, in April, etc. Snapshots across the globe. Stitch them all together into a GIF. Plot a frequency chart that tracks the commonness of the species through the year. That tells you when it might be leaving and when it might be returning. And this is all done using the software R. Every map that I'm going to show after this. I'll start with migration within the subcontinent. And this is Indian pitta, a really iconic species in the country. And you see that it spends the winter in South India and Sri Lanka. And as it becomes April, May, June, July, they move into Central and North India. And then again, as winter comes in, they migrate to the south. Birds breeding in the north and migrating south for the winter. So this is typical migration, the migration that we all learn about. Migration from north to south. And Blythe's Wobbler is an excellent example of that. We saw static maps of this earlier, but now we get to see it in action. Remember that individual birds are not being tracked. It is observations uploaded by bird watchers. And we're seeing how these observations or where these observations are uploaded are changing over time. So here you see during winter, the entire global population is in the subcontinent. Oh, sorry. Breeding in the south and migrating north for the summer. So this is something that we don't think of very often, but there are species that do this. We know that Pallas fish eagle breeds in India. We know that it breeds during winter, but what does it do during summer? In summer, it migrates to Mongolia mostly. And in winter, they're in the Indian subcontinent, mostly along the northeast and northwest of the country, right? And this is a species that breeds during winter in India and migrates north during the summer. Passage migration into Africa. I'm sure everybody knows about Amur falcon migrating from East and Northeast Asia through India into Africa. And this is it's a spectacular phenomenon that everyone should witness once in their lifetime. I still haven't, but in parts of Nagaland, Manipur, Mizoram, you can see aggregations of tens and hundreds of thousands of Amur falcons moving through in November. Eastward migration into Southeast Asia and Australia. White-throated needletail is a species that breeds in the Himalayas and in other parts of Asia. And almost the entire population migrates to southeastern Australia during the winter. And this is quite interesting because we don't think of migration from India to Australia, although we know of another example of Oriental pratincoal doing this. And this phenomenon was discovered due to a satellite tag. So white-throated needletail doing this. And then opposite migration from the south to the north. So we think of migration from the northern hemisphere down to either the tropics or the southern hemisphere. But we have many species that breed in Antarctica that breed during a northern hemisphere winter, which is the southern hemisphere summer in Antarctica. And during our summer and monsoon, which is their winter, they migrate up into the northern hemisphere and spend their time in the global waters, really. So this is Wilson's tom petrel, one example of this. Comparing migratory routes. This is brown shrike and Isabellian shrike. Both of them are common birds in different parts of India. What we see here is that there is some sort of spatial segregation during winter, but also during the breeding period, where brown shrike breeds eastwards of Isabellian shrike, and their wintering ranges somewhat mirror that. So they migrate in almost parallelly and in a southwestern direction. tracking new migratory routes. So yellow-browed wobbler, until recently, was thought to be a species that breeds in Eastern Asia, largely, and also parts of Russia, and migrates mostly to Northeast India and Southeast Asia. But over the last many years, increasing numbers of observations of the species have been documented in Western Europe. And this is a phenomenon that has now been documented. Almost every year, there are more and more individuals of yellow-browed wobbler wintering and passing through Western Europe, which is way off their original migratory range. Why is this happening? Is this phenomenon going to continue? Is it because of expansion of its breeding range? All of these questions remain to be answered. Some other interesting phenomena. Arctic wobbler. Arctic wobbler is a species that breeds almost in the tundra of Eurasia, in northern Russia, Norway, Finland. And previously, the species used to largely be present only in eastern parts, in eastern Russia and so on, and used to winter in Southeast Asia. But increasingly, birdwatchers and scientists have found that the species is expanding its breeding range westwards, and now it breeds all the way into Sweden and Finland. And the species, but although it's expanded its breeding range, it continues to winter in the same area. So there's some sort of migration memory, and now they move really, really long distances to their wintering grounds. And it's a very similar example with the eastern populations of northern meteor. Previously, it used to be mostly in Western Eurasia, but now they've expanded their range eastwards, actually not just to Northeast Asia, but into Alaska. And from there, they winter in Africa. The entire population winters in Africa. So it's a huge distance for them to fly. So some new learning and questions. Black-cap kingfisher, it was unclear according from our literature, Indian literature, about whether it was a winter migrant to India or a resident bird, but observations of bird watchers show categorically almost that it's a winter migrant to India and South Asia. And now that we know this, we know that also black-cap kingfisher populations are declining quite strongly across most of their range. And given this knowledge, we need to find out how to protect the species or find out what threats the species is facing only during winter in India, where it uses mangroves. So can its status be tied to mangroves? It's a question that needs to be asked and addressed. So all of these maps are downloadable at the Bird Count India website, and I suggest you go through all of the available migration maps, because there are some questions also that are asked about that in the assignment. Also, the code for anybody who wants to reproduce this is available at the GitHub link pasted below. Bird atlases. So one of the first bird atlases in the country was the Mysore Bird Atlas. It was the initial one that inspired the birdwatchers of Kerala to also come up with a statewide bird atlas. Mysore was for the city, Kerala is for the state as a whole. And they've come up with the most incredible achievement of birdwatchers all over the state coming together to monitor birds systematically. And as I mentioned earlier, the difference here is that the protocols are standardized. The entire state is divided into grids. All of these grids are uniformly monitored with the same protocols for the same amount of time, so that there can be comparisons made in space, and then relationships can be drawn with habitat, with various other factors, including built-up area, human presence, etc., to answer many questions about where birds are found. And many publications are rising out of this now, all thanks to a citizen initiative. Population trends. So population trends is an intrinsic part of bird conservation, understanding statuses of birds, whether they're declining, increasing, etc. And such trends are possible by following frequencies, which we discussed earlier, frequencies of reporting across time. So if these frequencies of a species are increasing, then the bird is increasing. If it's decreasing, it's decreasing. And there are some statistical techniques required to minimize various biases that come from where the observations are. But looking at the country as a whole, these are some trends. I'll start with the house sparrow. House sparrow, a number of us have felt that house sparrows are declining in the country as a whole. There have been a lot of media articles, a lot of theories about why they're declining. But actually looking at data, it appears that house sparrow is actually stable in the country as a whole. These methods, I'll come to where you can view the methods and where you can view detailed results later. Redneck falcon. Redneck falcon has declined considerably in the country as a whole and is a cause for worry. Why have they declined? This is a question that needs to be asked. Ashyprinia. Ashyprinia has increased in the country as a whole. And this might be because Ashyprinia are very generalist in terms of their habitat. And perhaps they're able to live in many human modified habitats. And the moment a natural habitat is converted, Ashyprinias are able to move in. So this is a theory that requires testing. But these are some insights that we get from analysis of this sort. And this analysis was done for 867 species in the State of India's birds. The State of India's birds report also found that house sparrow has remained stable in the country as a whole, but has declined in the big cities. So many of us were not really wrong. We have seen these declines, but it's only happening in the big cities. This is the report. I suggest that you all go through the report and the website. It's downloadable at www.stateofindiasbirds.in, and also look at the methodology. And this is Pacific golden plover. Before I get to this, this study was this project. The report was a collaborative initiative between a number of scientific institutions that came together to analyze this data and publish. And of course, it's all thanks to the thousands of birdwatchers around the country who have contributed knowledge. A number of species are of high concern, some are moderate concern, and this sort of a report allows high concern species to be prioritized by conservation and policy making bodies, including the government of India. One such high concern species in India is the Pacific golden plover. And you see that it's declined by around 90% in the last 25 years. And this is a decline that is mirrored in other parts of its range as well. The graph that you see on the left is from Singapore, where the species has almost disappeared now. Opportunities and challenges. So now that I've spoken about some things that can be learned from this data and some things that can be done with images, with in terms of migration, trends, etc. There are many opportunities that still remain. There are only a small number of people today actually using these valuable data sets and analyzing them. And one of the major opportunities is to systematically monitor birds more. What we had was unstructured information, right? People are birding wherever they want, and there's certain questions that cannot be answered like that. So we need more atlases. We need more long-term monitoring efforts with structured protocols. And these are efforts that can be initiated by citizens. And a number of people are now doing that, are increasingly starting to do that. And you can use these resources to ask more questions, right? With the data sets available and data sets growing as rapidly, the data quality, curation of the data quality is a challenge, right? And because these data sets are so large, there are various mechanisms that the different platforms have in place. All of these mechanisms, maintaining data quality is a challenge. So learning how to download this available data, this publicly available data, I think is a great opportunity. And a number of people don't make use of this. So there are resources on how to get started. There's a bird count video on the Bird Count India YouTube channel, that a couple of videos that explain how the data can be downloaded, and some preliminary analysis can be done on Excel and on R. R is statistical software, and Excel, that's something that most of us are familiar with. So downloading and analyzing data, you can do this easily once you watch the video. I suggest all of you watch the video because there are a couple of questions also that are based on this. And thanks to all of this, thanks to people downloading the data, analyzing it, thanks to people who are asking questions, using these data sets to answer them, the number of publications that are coming out of eBird data or out of citizen science data in general are increasing considerably. And along with these publications is our knowledge is increasing as well. And this is just in 2021, a number of publications and a number of new insights in Indian ornithology have come from publicly available citizen science data sets, often led by non-professional scientists, often led by bird watchers. And if you see, a number of these publications here are by bird watchers. And we hope that this increases considerably and a number of you download the data and start generating knowledge about India's birds. So I'll stop here. Thank you.
Thanks, Ashwin. That was a great session. Well, if anyone has any questions, you can enter them in the chat box and we can take that up.
I somewhat, I went quite fast through many of the topics and I wanted to leave some time for questions. So if any of you have questions, feel free to ask, especially about any details that I didn't get into. There's a question on chat, which Devika, can we? Is there any tool where I can import data from iNaturalist to eBird? Maybe this can be taken separately because it's not something that I spoke about here. But maybe you can get in touch with me directly, and I'll guide you through that process. Can you explain?
So maybe they can write to you. Sorry, Ashwin. Yeah, so I was just asking you if Bhagwan Kurade can write to you.
Yes, yes.
Yeah.
Please. Yeah. Can I explain how the data entered by citizens is verified? So there are some data quality mechanisms in place. These are different for different platforms. So for example, iNaturalist is community identified or community verified, in that any participant, any user of iNaturalist can come and can decide the observation, decide the identification of a species. And if two people agree on a certain ID, it becomes research grade, which then becomes publicly downloadable. But anybody can go and suggest another ID, which takes it out of this research grade status. So it's community identified. eBird, on the other hand, has a backend data quality system, which includes a set of filters. A set of filters are basically a set of species that have been documented to occur in a region. So this list of species, and there is seasonality and numbers set with that. Anything that does not fall within these numbers or within that season is then flagged. So when it's flagged, it doesn't immediately come into public output. Let's say I'm putting an observation of a yellow-browed wobbler, because I spoke about it, from Bangalore. This will automatically be flagged and will not come in public output, but will go to a group of reviewers, volunteer reviewers, who then look at all of these flagged observations, engage with the bird watchers, and discuss about whether there is any notes or any photos or any kind of documentation that can be provided, so that these observations can be verified and can stand the test of time. Because that's what's important. Eventually, all of these observations have to stand on their own merit. So if somebody is looking at it 10, 20 years from now, it's important that it has some documentation. And a combination of filters and reviewers tries to take care of that. Of course, it's a big challenge and it's a constantly developing process, but this is how it is. Data quality is maintained. So I hope I answered the next question as well. And Kasturi Rangan says, it will be great to understand your journey so far. Any other experience of a bird watching that was unique and enriching? Okay, maybe I'll come to this if there's time. Do we have, Deepak Gujarat, do we have trends that show if populations of house crows, black kites, and feral pigeons are exploding, especially in the big cities? In the country as a whole, yes, there are trends. And I won't speak of house crows and black kites. I'd like you to think of what the trend might be and go to the report and go to the website and see what has happened. But I'll talk of feral pigeons. Feral pigeons have exploded in the country as a whole. And they've increased more than any other species. And this is something that all of us could have guessed, really. But they are really, they do so well in human areas that they've absolutely exploded. And this comes with its own set of problems, perhaps own set of challenges. Yes, feral pigeons have exploded. What could a person like me who's a novice contribute to bird conservation? So multiple ways you can participate in many of these citizen science initiatives. Many of these initiatives are led by bird watchers, amateur scientists, and you can always participate in an initiative of that sort. So do check out maybe the Bird Count India website or various other online forums to find out where you can participate. What you can also do is you can go through what is available online, and you can find out more about birds in that region. You can find out which places have the greatest amount of bird diversity. All of this you can find out on the websites themselves, and you can use this information then in your own area. For example, if there's a lake, and as citizens who live in that area, you need to take a decision. Do we need to build something on that lake, or do we need to start some sort of development activity there? You can actually have an informed decision based on the amount of diversity that has been reported from that lake. You can also look at, for example, you can compare lakes. Some lakes are just like bowls. They don't have shallow areas. Some other lakes have shallow areas. Then you can compare bird richness in both of these lakes. And if it's more in the lakes with shallow areas, you as a citizen, as a person who lives in that area, can then suggest to your local development bodies that, see, when the lake is being developed, this is how it should be developed. So there are many ways in which you can leverage this information available to make the best for your environment, for your surroundings. Krishandu has asked, can you explain once again comparing frequency between years? Okay, so the general concept or specifically how to do it? So if it's specifically how to do it, like I explained in the talk, maybe it's best to watch the video again. But the general concept of frequency is that bird watchers upload bird observations in the form of checklists. And actually, this is a concept I didn't mention there, but there's a concept of a complete checklist, which has all species, which includes all species that were seen or heard during that period of time in that checklist. Let's say that I'm birding for 10 minutes. In that 10 minutes, everything, including crow, myna, pigeon, black-throated wobbler, anything that I've seen or heard is reported in that checklist. Now, let's say I've uploaded two checklists, one with black-throated wobbler, one without black-throated wobbler. If both are complete checklists, I can say that the frequency of me seeing black-throated wobblers is 1 out of 2. 1 out of 2 checklists, which is 50%. Now, if this becomes, instead of 2 checklists, it becomes 2,000 checklists. And I've seen black-throated wobbler in 1,100 of them, right? Then my frequency becomes 55%. Frequency of seeing black-throated wobbler. Now, with multiple people's observations, checklists coming into the picture across the entire country, there are really lovely insights that we can get about frequencies. You can compare this between years, of course. So frequency, you can look at how often I saw black-throated wobbler this year and compare it with last year. And then you can find out whether there are more black-throated wobblers this year. So actually, this is something that you can check for Taiga Flycatcher in Bangalore. I believe, I haven't actually checked the data, but I think that Taiga flycatchers have actually increased this year in Bangalore. And I'd leave it to all of you to check. How can reverse migration be explained? That is wintering in the north and breeding in the south. So that is because in the southern hemisphere, the seasons are reversed. So what is winter for us in the northern hemisphere is actually summer in Australia, in Antarctica, in New Zealand, all of these areas in southern parts of South America. So the seasons are reversed. So what is now becoming summer for us in India is actually the advent of winter in the southern hemisphere. So now our summer which is the winter for birds that are breeding in Antarctica and Australia, it becomes completely uninhabitable for birds that actually live in that area. So in birds of Antarctica cannot remain there. They have to come up north. So they actually come into the tropics. They come into what is our summer, which is a really clever tactic because they live their entire lives in summer. Apart from the CCAP, are there other apps that can help you identify birds, insects, and trees? Yes, there are. So Merlin is an excellent app to use for birds. It has an incredible AI, which you can upload photos, and you can it tells you what it's likely to be. But remember that these are just indications. So Merlin is an app. Merlin is a fantastic app to learn more about birds. Yeah, so these are just indicative. The best way to learn, best way to identify birds, etc., through field guides, through constant time spent in field. Okay. Have I missed any question?
I think you covered all.
Okay.
Yeah, there was one question which we had said we'll get back to if you have time.
Yeah. So inferences on data are made based on uploaded checklists by birders. So if a species is not reported in a region, okay, that's an excellent question and something, it's a challenge in citizen science at the moment. Challenge to have people participate from everywhere, not just certain regions of the country. It's not just the big cities. People must be interested in watching birds and documenting them all over the country, and many people are everywhere. It's just about helping that interest along. Okay, so to answer that specific question, we can know based on downloading the data or even looking online. So if you look at an eBird species map, you will be able to, or if you go to explore, you'll be able to see how many observations have been uploaded. So the line graphs that I showed, if you go to that page, you'll actually see below that there is the number of checklists also mentioned in another graph. And using the data itself for that region, the downloaded data, you can look at how many checklists have been uploaded. Using that, you can say whether it's because of a lack of birders or lack of checklists, or because the bird doesn't exist. So this is something that's easily verifiable because that information is out there. It's out there even on the maps. If you go to the distribution map of a species on eBird, there are certain cells which will not have any color. These are cells that do not have any observations. So you'll find that many parts of Russia, some uninhabitable parts of the world don't have any birders or don't have any checklists at all. So there you can say that yes, the species, we don't know whether it's present or not because nobody has watched birds there or nobody has documented birds from there. Yes. Yeah. Devika will share my email with everybody. So would you need to normalize all data related to frequency counts? Not quite. We don't need to normalize it according to that because frequency is to an extent independent of how many checklists there are. So if you have 10 checklists, you can still calculate a frequency. If there are 1,000 checklists, you can still calculate a frequency. And frequency can be calculated as long as there are some number of checklists from an area. But the two are completely different in that when you have 1,000 checklists, you have much more confidence in your frequency estimate than when you have 10 checklists. And this is a concept that is explained in the State of India's Birds methods. I suggest you go through that. With 1,000 checklists, you'll have less wide confidence bars. So in the graphs that I showed you, I hope you saw some ribbons around the line, and this indicates the level of confidence in that frequency estimate. So now that confidence increases and those bars decrease as you have more and more checklists from an area or for a species. I also mentioned that there are some statistical techniques that are important to use while analyzing eBird data. And I'll briefly mention a few of these. I didn't do that earlier. So there are three main challenges. There are biases in space. In that there are certain areas that have more bird watching than others. So for example, if I'm comparing, let's say, Arunachal Pradesh to Assam. So Assam has much higher human densities than Arunachal Pradesh. So Assam has much more information than Arunachal Pradesh. So now while comparing these two, let's say I want to find out the frequency of a bird present in Assam and Arunachal Pradesh. Now, if I look at it, if I actually calculate the frequency just like that, I'm effectively going to get the frequency in Assam because that's where most of the birding happens. So it's important to be able to normalize or standardize in space. So you try and give equal weightage to Assam and to Arunachal Pradesh. And if you look at the entire country as a whole, to break the country up into small grids. In State of India's birds, it was broken up into 25 by 25 kilometer grids. And every grid here is given equal weightage. So for example, a grid which has a huge amount of birding in Bangalore gets the same amount of weightage in that one frequency value effectively compared to a grid in the outskirts of Bangalore, which has much less bird watching. So that way you're standardizing according to space and then you're averaging across space. So that is one way to deal with that bias. Then you have bias in time, in seasons. You might have all seen that bird watchers watch birds more during winter than in summer in India because summers get hot, monsoons get rainy. So it becomes difficult to go out and watch birds and document them. So a lot of the bird watching actually happens in winter. So now what we need to do is standardize across space because there are some birds that are there during summer and monsoon, but not during winter, right? And in different parts of the country, birds might occur at different times. So you need some way to standardize to the average month. So now what we do is every month gets equal weightage. So you find statistical means to be able to give equal weightage to each month. So these are two of the most important reasons to standardize data statistically. So I hope that clarified that to some extent. Any other questions? You also need to standardize according to effort, which is basically bird watchers spend different amounts of time birding. I might spend 15 minutes birding today, but 1 hour birding tomorrow. And this also you need a way to standardize according to median effort. And this is why systematic monitoring programs like atlases, the need to standardize across space, across time, across effort, birding effort, all of this is removed, and which is why systematic initiatives are so valuable. So all of us should help initiate systematic monitoring efforts driven by birdwatchers and the public, driven by through ourselves in a sense, in every part of the country.
Great. Thanks so much, Ashwin. So last chance for questions. Okay, if there are no more questions, it's past 5. So I think we can end the session. Thanks a lot, Ashwin. Like a very valuable session. Oh, just now a question came in.
Okay. Okay, let me quickly answer. Research grade is a concept in iNaturalist that determines whether a record will be publicly available or not. If it's research grade, it can be publicly downloaded and it shows up in the maps. You can also download the observations that are not research grade, but they will not show up in the public maps. It's just a way to ensure that the community has verified the identification of that species. And the maps that we see, we wanted to actually reflect the distribution maps of that species. So which is why research grade is an important concept there. Okay.
Great. Yeah, I think it's safe to end the session. Thanks a lot, everyone, for joining in, and Ashwin for taking out the time and talking to all of us today. Great.
Thanks, Devika, and thanks everyone.
Bye.
Bye.